Dear students, in this video we are going to see design and analysis of algorithms lab exercise on Dijkstra's algorithm to find the shortest path from single source to all other vertices using the greedy method. So the objective here is, in the graph we have to choose any source, any vertex as a source, and from the source we have to find the shortest path to all the other vertices. So that is what the objective. So this Dijkstra's algorithm will be working for both directed as well as undirected graph. So here we can choose any node as a source. Say for example, you can select 6 as a node source, or 5 as a source, or 1 as a source. Any node can be selected as a source, and from that source we have to find the shortest path to all the other vertices. Similarly, in the case of directed graph as well, we can choose any one of the node as a source node, and from that source node we have to find the shortest path to all the other vertices. And one more thing, for the, in a graph this is the vertices and this is the edges. The edges will be having a cost with the positive value. That is the condition. The cost should not be a negative value. So the Dijkstra's algorithm objective is to find from a single source we have to find the shortest path to all the other vertex using graph theory. In graph theory, and then the weight assigned or the cost assigned in the edges should be a non-negative weight, and we are going to solve it using the greedy method. And graph means, we know in the graph we have the vertex and all the vertex are connected with the edges, and we are going to choose any one of the vertex as a source, and from which we are going to find the shortest path to all the other vertices, and the weight assigned to the edges should be a non-negative value. And what will be the output of this algorithm is, we will be getting the shortest path from a single source to all the other vertices. Okay. So now, to understand this, we are going to take an example, and this is a directed graph, and for this directed graph we are going to take A as our source. We can choose any node as a source. In this case we are going to take A as the source. From the source A we are going to find the shortest path to all the other vertices. Okay. So now to do that using this Dijkstra's algorithm, let me take for example one more thing. To find the distance of this particular vertex means, what is the from this A means, what is the formula to do that is, for example, I will be checking if the distance of the vertex V is greater than the distance of U vertex plus the weight of vertex U to V. If this value is less than the value of this vertex, then I have to update this vertex V with the new distance. So distance of V will be updated with distance of U plus weight of U comma V. So for example, if you consider this as U vertex and this V at vertex, if I want to find the distance of this V vertex, how will I find it? I have to add the distance of U plus the cost of this will give the new distance of this vertex V. So that is what given here. So initially the distance of A to A, what will be here? I am considering A as my source. So what is the distance of A to A? Obviously we know the distance of A vertex to A vertex is 0. And for all the other vertex we don't know what is the distance, right? So we are going to initially take all the vertex distance as infinity, because we don't know what is the distance from A to C or A to B or A to D or A to E. So we are initially considering the distance as infinity. So let us start doing. I am going to have an array Q where I am going to initialize this Q array with all the vertex. What are the different vertex here? We have A, B, C, D and E. So these are the vertex, okay, which we have in this graph. And then we are going to have another array. Let us say it is S array, and here we are going to write all the selector vertex. Okay, so initially we know the distance from A vertex to A vertex is 0, and to all the other vertex we don't know what is the distance, so we are initializing all other with infinity. What is the next step we have to do is, from this value we have to choose who have the minimum distance. Who have the minimum distance here? 0 have the minimum distance. So what I am going to do, I am going to choose this distance 0, and that is the distance of A. So I am going to, now the selected vertex is A. Now what is the next step we have to do is, we have to see from A who are all the neighboring vertex of A. Who are all the neighboring vertex of A? From A we can go to B, and from B can go to C. So that is what given in this graph. So the neighboring vertex of A is B and C. So for B and C we have to find the distance. So we already know how to find the distance of a new vertex. So let us say we want to find the vertex of B now. So how will we find? We have to find the distance of U plus the cost of this edge, right? So 0 plus 10. So 0 plus 10 we will be getting 10. So we have to, according to formula, we have to say what is the distance of vertex V. Now the vertex V distance is infinity, but after adding d of u plus weight of u comma v, we got 0 plus 10, that is 10. So 10 is less than this distance of V. Okay, so we can update this distance of V with the new value. So now we are going to update this infinity with the new distance we found as 10. So now instead of infinity we are going to assign the value as 10. Similarly, now we have to find the next neighbor's distance, that is C. So how will you find the cost of C? 0 plus 5. So 0 plus 5 we will be getting 5. So there is infinity weight is now updated with the new distance 5. So here also we are going to update it, and then we don't know again what is the distance to D and E, let it be infinity itself. Then what is the next thing we have to do? We have to choose who is the minimum distance among all this. So who is having the minimum distance? 5 is having the minimum distance. So we have to choose 5 as the vertex. The next selected vertex is C. That is the 5 is the weight of vertex C. So we are going to choose the minimum 5. Now what is the next thing we have to do? From 5 we have to see. 5 means from C, the weight is 5 is for C, right? So from C we have to see who are all the neighbors of C vertex. So who are all the neighbors of C vertex? From C we can go to B, we can go to D, as well as we can go to E. So we have to find the distance of all of this. So let's start with this. From C we have to see what is the distance to B. So already we know the cost of this C vertex distance is 5. So plus the weight of this is 3. So 5 plus 3 we got is 8. But what is the already available weight of this one? 10. So 8 is less than 10. So we can update it with the new value, right? So we are going to update this 10 with the new value we got is 8. So here again I am going to update this 10 with 8. And the next thing is we have to find the distance from C to D. So already we know what is the distance of C, that is 5, and then the weight of this is 9. So 5 plus 9 we will be getting 14, which is less than this infinity. So to the distance we can now, the infinity can be replaced with the new weight 14. And then now from C to E, how to find the cost? The distance of C is 5 plus the weight is 2. So 5 plus 2 is 7, which is less than the infinity. So now the infinity will be now changed to 7. Right? So now what we have to do next? Now we have to choose who is the minimum among all this. The minimum among all this is 7. So that is the weight of who? E. So now the selected vertex is E. Okay. So then what we have to do? Then again we have to see from E who are all the neighbors. So that is what E is, what we selected now, right? So we have to say from the selected vertex E, we have to say who are all the neighbors. Who are all the neighbors of E? That is A as well as D. So but A we have already calculated the distance and we have already chosen it as 0. So now we don't want to update it because it's a selected vertex, right? No, so we don't want to update the value of this one. Now we have to update the value of D. So from E, if I want to go to D, what is it? How will you calculate? Sorry. Now we are from C. What is it? So from E, we want to go for this. Already the weight of this is updated as 7, right? Okay. So now from E, we have to see for D. So how will we find? The distance of E is 7 and the weight of this is 6. So 6 plus 7 will be getting 13. So we are going to update. So infinity is greater than 13. So we will be updating this infinity with the newer weight 13. So what already already we have updated it with 14 in the previous step, right? So now 13 is less than the 14. So the new value we have got is 13. So again 14 is now updated with 13. And so all the remaining thing we will be writing as it is. So among all this, now we have to see who is this okay. So this is already selected, so we don't want to write it again. So now 13 and the remaining is 8. So 5 we don't want to redo, 7 is already selected, 5 is selected, is already selected, 0 is already selected, so we don't want to worry about it. So what is the next thing usually we'll do? After this we want to find who is the minimum among these two. The minimum distance among these two is 8. So we are going to select this 8 and this 8 is the distance of the vertex B. So now we are going to take B as our selected vertex. So what is the next thing we'll do? We have to find from B who are all the neighboring vertex. So from B we can go only to D. So we have to update we have to say what is the distance through B. So already we know from B the weight is 8 and the cost is 1. So 8 plus 1 is 9. Already we have 13 here. So the 9 is lesser than 13. So we'll be updating this 13. So updating 13 with the 9. So here also we will be putting, instead of 13 we found a new weight, that is 9. Right, so that's it. So for all other vertex we found the lowest. So at present who is our minimum distance? 9. So that is of vertex D. So we are going to take D as our selected vertex. So we done it. We found from A, we found the shortest distance to all the other vertex. What are they? From, if I want to go from A to B, the shortest distance is 8. If I want to go from A to C, the shortest distance is 5. If I want to go from A to D, the shortest distance we found is 9. And if I want to go from A to E, the shortest distance we found is 7. So we found it, right? Now let us take a scenario and so we know what is the distance. Let's take from one, so our source vertex is E. Let us take a scenario. If I want to go from A to D, what is the path to achieve? So A to D, if I want to know, the distance we found is 9. But we want to know what is the path to move from A to D with this distance 9, right? So our objective is, now I have to go from A to D. Already we know the distance is 9, but we want to know the path. So we are going to find the path. So let's start from D. So we are going to start from D. So after that we are going to make a pointer here for this D. And now we will be going to the previous step. So in the previous step, if you see here, this is the previous step. And if you see here in the previous step, there is a change in the distance. So if there is a change in the distance, then we have to see who is the minimum among in this. So in this, the minimum is 8, that is the distance of B. So the next one is B. So we have chosen it. The pointer will be coming here. So we have to move to the previous step as usual. If you go to the previous step, there is no change in the distance. If there is no change in the distance, then go to the above previous step. So that is 10. And if you go to the previous step, there is a change from 8 to 10. So if there is a change, then we have to say in that row who is having the minimum distance. That is 5. That is belong to C, right? So we have to choose that. So I am going to choose C. Again, we have to again from this 5, we have to go to the previous step, that is this. So if you compare the value of phi and infinity, there is a change in the distance. So what we have to do, if there is a change, in that row we have to see who is having the minimum distance. That is 0, that belongs to the vertex E. So we reach the source. So this is the path to move from A to D. So if I rewrite it, I can write like this: A, C, B and D. So if I want to move from A to D, this is the path. So first I have to move from A to C, from C to B, and then B to D, finally we operate. So how will you bring this cost? If I want to move from A to C, what is the that from this table we can see, we can so if I want to move from A to C, the distance the distance is 5, and then if I want to move from C and D, the next distance we have is 3. So for example, C to B, what is C to B? The distance is 3, so 5 plus 3, and then B to D, from B to D if I want to move, what is the cost of it? 1, so plus 1. So if you add all these things, we will be getting the answer as 9. So now we have found the path and the cost of it. So if I want to move from A to D, the path we have found is we have to move from A to C, C to B and B to D. So the cost from A to C is 5, then C to B is 3, C to B is 3, and from B to D it is 1. So when you add all this thing, we got the distance also as 9. So this is how we have to find the shortest path from the source. Okay, and also we found the path. Now I hope you got it. Now we have to let us discuss the algorithm of it. So this is the algorithm to find the shortest path from the source to a particular source to the all other vertex. So here first we have to take we know what is the first thing we did. The first thing we did is from A to A. We have taken A as our source vertex, and the distance to A is 0. So that is what we did here. The distance of the source is initialized with 0. And then what we did for all the vertex, we have started from the source. We are taking from the source S. We are going to start from S. Who is our S now? A. We are going to take A as our source. So for all the vertex from the source, we have to find from A to, for all the vertex we have to find the distance, right? Here our source is A. From A we have to find the distance to all the other vertex. So that is what the for loop. For all the we have to find from the source to all the other vertex, we have to find the shortest path. Then initially what we did, from A to all the other vertex we have initialized this as infinity. From A to A the distance is 0. To all the others we initialize with infinity, right? So that is what we did. So distance of all the other vertex, like each and every vertex, let it be first time it would be B, C, D, like for all the other vertex we are assigning it as infinity. Then we took two arrays, right? One is S array, another one is Q array. This Q array is initialized with all the vertex, and S array have the selected vertex. So initially the S array doesn't have any selected vertex, so that is null. And the Q array have all the vertex. V means all the vertex, right? Capital V. So what are all the other vertex? In Q we assign A, B, C, D and E. So Q is assigned with all the vertex. So we are initializing the S array and the Q array. Now we have to check whether the Q array is not null. Okay, if it is not null, Q array means this array. Every time we are finishing one vertex. So first time in the Q array A will be done, next time we did C, and the next time we did E, and next time we did for B, and finally we did for D. So until the Q array become null, we have to continue. So that is what we did is, while Q is not null, then what we have to we did after that, we have to choose who is the minimum distance among all this in the Q array, right? So that is what here we have to choose a minimum distance from the Q array. So and that minimum distance is assigned to U. And then that minimum distance U will be assigned to this S array. So what is present in the S array? All the selected vertex are available in the S array. So in the first time, the minimum distance is A. So that A is taken in the selected vertex S, right? Selected vertex array S there. In the next time, who have the minimum distance 5, that is of C vertex. So that is assigned to the array S. Next time, who have the shortest distance 7. So that is of E vertex. So E is assigned to S. So that is what done here. So we want to find who is having the minimum distance, that is U, and that U is assigned in the selected vertex array S. And then what we did, so we chose who is having the minimum distance. So in this case, C is having the minimum distance. Then what we did, we find who are all the nearing neighbors of C. Who are the near neighbors of C? B and D, right? B and D and E. So that is what we are finding. For all the neighbors of U, we are going to take and we are going to calculate the distance. So we already know we will be calculating the distance by this formula, right? So that formula is available here. So if the distance of this V is greater than the distance of U plus the weight of U comma V, then we have to update the distance of V with this new weight. So that is what we are assigning. If it is the new weight is lesser than the weight already available or the distance available in this, then we will be updating this new distance to this vertex V. So this will be repeated, and then we are assigning this U, the selected vertex, to this path of V. So this is how we will be finding for all until this Q array become null, which means first time we selected A, then we go for C. So likewise, we will be selecting each and every vertex until we complete for all the vertex in this Q array. This process will be updated, and then we will be finding who is having the minimum vertex. That minimum vertex will be taken to the selected way. So this process will be, this while loop will be done until the Q array become null. And finally, the new updated distance will be written from this algorithm. So this is what the algorithm. So you have to implement this algorithm in your lab to find the shortest path from a single source. Okay, so we did using Dijkstra's algorithm. And what is the application of this Dijkstra's algorithm? Where are the places we are using this Dijkstra's algorithm? In the traffic information system, especially in the Google map, to find the shortest path from one place to another. This Dijkstra's algorithm is used, and even in computer networks to do the routing. Again, this Dijkstra's algorithm is used to find the shortest path from one particular system or router to all the other, or from one router to all the other places. To go to find the shortest path, we are using this Dijkstra's algorithm. Hope you got it, and you have to implement this algorithm. Thank you, ma.